This is boost converter. Boost converter controlled by the voltage mode control loop. This is voltage control loop. Here the load voltage is regulated with the help of this voltage control loop. In this voltage control loop, we are using PI controller here. So the PI controller will check the error voltage. That is, the reference voltage is 48 and the load voltage is provided here as a feedback, and error is provided to the PI controller. The PI controller will generate duty ratio depending upon the error voltage. And the duty ratio is given for pulse generation. The generated pulses is given to the switch here. When the switch is on, the voltage source will be boosting the inductor. That is, the inductor will be charged and it will flow through the switch. When the switch is off, the inductor will start to discharge. So it will act as a voltage source. So it will combine with this input voltage source. Both will be connected in series and the output voltage will be input voltage plus inductor voltage. So by this we are getting the boosted voltage at the load side. How much the voltage will be boosted depending upon the duty ratio and the inductor ripple current. The inductor ripple current plays an important role in the inductor value. So based on that, the boosted output will be obtained by the load side. Here the input voltage and the input current with input power is provided here. Input voltage is 12 volt. Input current is around nearly 8 amps to 10 amps. And the power is around 100 watts. So this converter handles the 100 watts power. And the load side voltage and current. The load side voltage is around 48 volt. Current is around 2 amps or 2.1 amps. So the power is around 100 watts. Here the actual voltage is 47 volt we are getting. That is, the ripple voltages ranges from 46.8 volt to 47.5 volt. And current is around 2.05 amps. The ripple current is from 2.03 amps to 2.06 amps. 6 or 2.07 amps. So 0.04 amps and voltage is around 46.8 to 47.5. So 0.7 volt is the ripple voltage. And settling time is also, here the voltage is settled at nearly 0.01 second. Okay, and the controller input and output, we can see it in this. Controller input is error voltage. Here initially the error is high and it is gradually reducing and it is nearly 0 here. And this one, second one is duty ratio. How the duty ratio changes here. And these are the gate pulse, inductor current, inductor voltage. Here, when the pulse is on, the inductor will be charging. So the inductor current will increase. When the pulse is off, the inductor will be discharging. So the inductor current goes to 0 here. That is, it will be discharging. Okay. This is with PI controller. We replace this PI controller with fuzzy controller. So here if you see means input everything is same only. Input voltage is 12 volt, output voltage is 48 volt, load resistance everything is same. Just the controller is changed here. Here fuzzy controller is already designed for to run that simulation. Type fuzzy in command window. A dialog box will open. Import from file DC voltage control. Okay, now it is loaded. Then we have to export it to workspace in order to run the simulation. Here the name should be DC voltage control. Okay, we have exported to the workspace. After that, we have to run the simulation. Here, we have to run the simulation in this. Okay, in this if you see means the input and output of the fuzzy control. The input initially it is high, then it is reaching 0 here because the error is 0. And this is the duty ratio here. The duty ratio is oscillating between 0.3 to 0.6. Okay, and this is the output voltage. Okay, compared to PI controller, the oscillations are less. Okay, 47.62, 47.85. So 0.25 volt ripples are there. Similarly for current 2.07 to 2.08, so 0.01 amps ripples are there. After that, here this is the settling time. The settling time will be around at this point, and that is 0.12 millisecond. Okay, the voltage and current is settled around 0.12 millisecond. This is much quicker than the PI controller. So the accuracy is increased, the voltage ripples are reduced, the speed is also increased, the settling time and all it is reduced here. Okay, so fuzzy controller provide better performance than the PI controller for this boost converter circuit. Here in the report, we have provided tabulated the results. Here for PI controller, what is the load voltage ripple? Settling time. For fuzzy controller, what is the settling time? Rise time, steady state error. Like that, everything is mentioned here. Steady state error means the error between the, that is error voltage. Difference between the reference and the actual voltage. That is steady state error. Load voltage ripples means that oscillations. Okay.